Hello everybody, today I can find missing sides and angles of right triangles by drawing and labeling a picture and using SOHCAHTOA or Pythagorean Theorem. So this is very similar to the previous lesson that we did, except now I'm not going to give you a picture, you're going to have to draw your own picture. Let's just quickly talk about what you need to know math-wise. For right triangle problems, there are two types of problems. There is SOHCAHTOA, and there is Pythagorean Theorem. We use SOHCAHTOA when there's an angle involved. We use Pythagorean Theorem when there's no angle involved. If it's only sides, then we're using Pythagorean Theorem. If there's an angle involved, whether we're finding it or given it, then we're using SOHCAHTOA. There's two types of SOHCAHTOA problems. If you're finding a side, then we're going to cross multiply. And when you're finding an angle, you're going to do inverse sine, inverse cosine, inverse tan. For Pythagorean Theorem, A and B are the legs, and C is the hypotenuse. Now, a prerequisite for this lesson is that you know how to do Pythagorean Theorem and finding sides and angles using SOHCAHTOA. So if you haven't done those yet, go back to those lessons now, and once you're comfortable with that, you can come back to this. Number one, in triangle MCT, the measure of angle T equals 90. So, since angle T equals 90, I know that it has to be a right triangle, and T must go at the right angle. Now, M and C are interchangeable. As long as I know that T is the right angle, that's all that matters. MC is 85, CT is 84, TM is 13. That's the hard part. That's the only thing that's new is creating your picture. Now it's asking for the sine of angle C. So since it's asking for sine, I know that we're using SOHCAHTOA. And the formula for sine, theta, is opposite over hypotenuse. So I'm dealing with angle C. So my first step is to label my H, which is my hypotenuse. The angle always connects the H to the A, which makes this my O. So it's asking for sine of C, so theta is C, opposite is 13, hypotenuse is 85, and because it's just asking for the ratio, because it's just asking for sine, cosine, or tangent of an angle, you don't have to go any further, you don't have to cross multiply, you don't have to find inverse. When it's asking for sine, cosine, or tangent, you're just setting up the ratio. That's it. Draw your picture, label, and then from there, do the same thing that we've been doing. We're going to skip that one. Let's take a look at number 3. An equilateral triangle has sides of length 20. So I'm going to draw an equilateral triangle, and I'm going to fill in that the sides are 20. To the nearest tenth, what is the height of the equilateral triangle? So I'm going to draw in the height. And what I just did when I drew the height in is within my triangle, I have a right triangle. It's asking for the height, so that's what I'm trying to find. And since it's an equilateral triangle, this base is being cut in half. So now, within my picture, I have a right triangle. Are there any angles involved? No. So since there are no angles involved, only sides, I'm going to use Pythagorean Theorem, a squared plus b squared equals c squared. The legs are 10 and x. The hypotenuse, the long slanted side, is 20. A and B are interchangeable, but the hypotenuse C, the long slanted side, has to be 20. 10 squared is 100. 20 squared is 400. To solve for x, I'm going to subtract 100. Now, to get rid of the squared, I do the square root of both sides. It's asking to the nearest tenth, so I'm going to go to my calculator. I'm going to type in radical 300, second radical 300. To the nearest tenth, I get 17.3. And that's my answer. So I drew a picture. I just drew whatever it told me. It told me there was an equilateral triangle. So I drew an equilateral triangle with sides 20. It wanted me to find the height, so I drew in the height. And once I did that, I ended up with a right triangle. I had no angles involved, so I used Pythagorean Theorem to find the missing side. Let's skip ahead to number 6. A 28-foot ladder is leaning against a house. So, let's see my house. Make it look like a house. There's a ladder leaning against it. Well, when a ladder leans against it, it doesn't go straight up and down, it goes on a slant. So there is my ladder leaning against a house, and I end up with a triangle. It says it's a 28-foot ladder. So since I made my ladder look like a ladder, hopefully it's pretty obvious that the ladder is 28. The bottom of the ladder is 6 feet from the base of the house. So where is that 6 going to go? We'll read very carefully. Bottom of the ladder. This is the bottom of the ladder. Base of the house. Base means bottom. This is the base of the house. So the base of the ladder to the base of the house is 6. That's 6. And you just need to read carefully. Find the measure of the angle formed, so it's asking for an angle, by the ladder and the ground. Where does the ladder hit the ground? Right there. That's my picture. That's what's new for this lesson. Now that I have that, it's, well, the same thing we've been doing for days. There's an angle involved, so I know I'm going to be using SOHCAHTOA. Label your H, your A, and your O. Hypotenuse is H. The angle always connects the H to the A, which makes this my O. Out of A, O, and H, which two are involved? Well, A is 6, H is 28, A and H is cosine. So I start by writing cosine of theta equals A over H. I substitute my values in. Theta is always the angle. It's X in this example. A is 6, H is 28. Now sometimes I do inverse and sometimes I do cross multiplication. When I'm finding an angle, when I need to get rid of the cosine, I'm going to do inverse cosine. When x is a side, when x is part of the fraction, that's when I cross multiply. To find an angle, to get rid of cosine, I do inverse cosine. And make sure your calculator is in the proper mode. It should be in degree mode. So, where's my calculator? Let's just make sure I'm in the right mode. I hit mode, and degree should be highlighted. Second cosine, alpha y equals enter, 6 over 28. To the nearest degree, that's going to be 77 degrees. All right, I'd like to do one more. Let's take a look at number 7. This is a better one. Yeah, 7's good. A 20-foot support post leans against the wall, making a 70-degree angle with the ground. I'm going to give you about 20 seconds right now to draw that 20-foot support post leaning against the wall, making a 70-degree angle with the ground. Take about 20 seconds. You try to draw your picture on your own. I have a wall. There's a support post leaning against it. Things lean diagonally. So it's a 20-foot post leaning against the wall. There's my triangle. The post makes a 70-degree angle with the ground. Post, ground. Where does the post hit the ground? There. That's 70. To the nearest tenth of a foot, how far up the wall will the support post reach? I want you to take about 15 seconds, and I want you to try and put the X in the correct spot. Just make this a bit bigger. I want you to try and determine where the X is going to go. How far up the wall will the support post reach? This is what they're asking. This is how high up the wall the post will reach. That's the distance from the ground to the top. So, since there's an angle involved, SOHCAHTOA, I'm going to give you about 30 seconds or so to label your H, your A, and your O. Determine if it's sine, cosine, or tangent, and substitute your values in. H, A, O. H is 20, O is X, sine. Sine theta equals O over H. Theta in this example is 70. Theta is always the angle. O is X. H is 20. Since X is in the fraction, I'm going to have to cross multiply and solve. First, I like to always type in the trig function sine of 70 and make it into a decimal. I find it less confusing. 0.9396 dot dot dot. Again, that dot 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 means there's more after the 6, but I'm not going to write the whole thing out. But when I do the calculation, I'm going to utilize that. 1 times x is x. 20 times 0.9396 dot dot dot. I'm going to do 20 times, and I'm going to tab up and copy and paste that. To the nearest tenth of a foot, it's asking. That's going to be 18.8. So there's nothing new math-wise. If there's a right triangle, it's going to either be Pythagorean Theorem or SOHCAHTOA. If there's an angle involved, it's SOHCAHTOA. If there's no angle involved, just sides, then it's Pythagorean Theorem. Within SOHCAHTOA, if you're finding a side, you're going to cross multiply. If you're finding an angle, that's when you do inverse sine, inverse cosine, inverse tan. There's nothing new here, there. What's new for this lesson is you have to draw your own pictures. So when you draw your own pictures, make it look as much like the real situation as possible. If it's a ladder leading on a house, show me the ladder, show me the rungs, show me the house, because you're going to be a lot less likely to make a mistake if you make things look like what they actually are. Make sure you put an X on what you're trying to find, and make sure you read very carefully when you're doing that. All right, reading is so important for this, so please be very careful. We're going to spend 2 days on this lesson, and we're going to quiz at the end of the second day. It's going to be very straightforward. It's just a matter of drawing your picture, getting all the numbers and variables in the right spot, and once you do that, you're just going to apply what you learned about SOHCAHTOA and Pythagorean Theorem. If as of right now you're not comfortable with SOHCAHTOA and Pythagorean Theorem, then go back to those lessons and get comfortable with the math itself before we integrate it with the word problems. Your classwork/homework is to finish this assignment, and I hope everybody has a great day.